Hi everyone, I am Dr. Subbarao from RVIT Institute of Technology. In this video, I am going to explain pi molecular orbitals and their energy level diagrams. First of all, we have to know the properties of formation of pi bond. And the next one is the pi bond is formed by the lateral or sidewise or parallel overlapping of atomic orbitals. So there are several overlappings based on the atomic orbitals. SS overlapping, SP overlapping, PP overlapping. During these overlapping, sigma bond is formed. For SS overlapping, one s orbital overlap with another s orbital to form the SS hybrid molecular orbital. And in sp overlapping, one s orbital overlap with the one p orbital of another atom and forms the sp hybrid molecular bonding orbital. And the next one is the pp overlapping. In this pp overlapping, the pz orbital of one atom overlap with the pz orbital of another orbital to form the pz hybrid molecular orbital. This is the formation of a sigma bond. But according to the molecular orbital theory, the pi bond is formed due to the parallel or lateral overlapping. Why? The p orbitals are, there are three degenerate p orbitals, px, py and pz. The pz orbitals undergo axial overlapping. That means due to the axial overlapping, the pz orbitals forms the sigma bond. After formation of sigma bond, the remaining py and px orbitals are parallel to each other. That means they are not directly overlapped with each other. Hence, they undergo sidewise overlapping. Due to the formation of side overlapping, pi bonds are formed. Here, the pi bonds are formed due to the lateral overlapping and forms the equal number of molecular orbitals. For example, here px or py. This is the atomic orbital of first atom and another atom having the px or py orbital. These two atomic orbitals undergo lateral overlapping to form the hybrid molecular orbital of p pi bond. P pi molecular orbital. This is the formation of pi bond. Next one is the pi bonds are weaker than sigma bonds due to the minimum extent of overlapping. So here sigma bonds are strong bonds. Strong bonds means they are independent bonds. They forms directly by the overlapping of two atomic orbitals. But here the pi bonds are dependent bonds. Dependent means after formation of sigma bond, then only pi bonds are formed. Here, the sigma bonds are having the more overlapping nature. That means they have the high extent to overlap with the orbitals. Hence, sigma bonds are highly strong bonds. And these pi bonds have very weak bonds. That means they have lesser strength. That means the bond dissociation energy of pi bonds is very low when compared to the sigma bonds. Next one is the pi bonds are formed after the formation of sigma bonds. So without formation of sigma bond, the pi bonds are never formed. And next, the pi bonds are formed by the overlapping of p orbitals or d orbitals. Here, pp overlapping, pd overlapping, and dd overlapping. That means the p orbitals of a first atom overlap with the p orbitals of the second atom, or the p orbitals of a first atom overlap with the d orbitals of the second atom, or the d orbitals of first atom overlap with the d orbitals of second atom. This type of interactions gave the pi bonds. Here, how many type of interactions are there? There are two types of interactions, homo interactions and hetero interactions. Homo means, here if you see the SS means both s orbitals undergo axial overlapping and forms the sigma bond. Here Sp, this one is the hetero overlapping. That means one s orbital and one p orbital. They overlap with each other and forms the molecular orbital. This one is the hetero overlapping. And here P, both p orbitals undergo axial overlapping and form the sigma bond. So this is the homo overlapping of p orbitals. Similarly, the pi bonds are formed due to the homo and hetero overlapping of p and d orbitals. Here, p pi interactions. How p pi interactions were going on? The p orbitals of first atom interact with the p orbitals of the second atom. This type of interactions are called the pp interactions, and they forms the p pi molecular orbitals. And next one is the p pi d pi. So the p pi d pi interactions, the p orbitals of first atom interact with the d orbitals of the second atom. Here p pi d pi interactions are formed. Here the molecular orbitals formed by the p pi d pi interactions are p pi d pi molecular orbitals. And the next one d pi d pi. That means the d orbitals of first atom interact with the d orbitals of the second atom and forms the d pi interactions and produces the d pi molecular orbitals. This is the type of interactions. Here p pi and d pi. These comes under the homo interactions, and p pi d pi comes under the hetero interactions. So these type of interactions will produce as the pi bonds. And next one, unlike sigma bonds, pi bonds do not affect the shape of a molecule. So the shape of molecule will be affected by the sigma bonds. If sigma bond will changed, the direction of the sigma bond changed, then only the shape of the molecular orbitals also changed. That means distorted molecular orbital structures was formed by the changing sigma bonds. But this pi bonds do not affect the shape of the molecules. And next one, single bonds are the formed. Single bonds are always sigma bonds. In between two atoms, if any single bond is present, that is the indication of formation of sigma bond. But triple bonds and double bonds, they are having pi bonds. The first formed bond is the sigma bond. Then after formed bond is the pi bond. For example, here we see the single bond. This single bond is the sigma bond. And next double bond. Double bond in the sense the first bond is the sigma bond and the second bond is the pi bond. Here one sigma bond and one pi bond. This is the formation of a double bond. And next comes to the triple bond. For triple bond, here the first bond is the sigma bond. After that, pi bonds are formed. Here, the pz orbitals undergo axial overlapping to form the sigma bond, and next px and py orbitals undergo lateral overlapping to form the pi bonds. Here, one pi bond, one sigma bond, and two pi bonds. Total 3 bonds. Here, this is the formation of triple bonds. Next one, formation of pi molecular orbitals. How pi molecular orbitals are formed? Here, when p orbital of first atom react with or coupled with the p orbitals of second atom, which undergo p pi interactions, forms the molecular orbitals of p pi molecular orbitals. Here, the number of molecular orbitals is formed is equals to the number of atomic orbitals that are combined. So how many orbitals are combined with each other? They give the same number of molecular orbitals. If two atomic two atomic orbitals are combined with each other, they form two molecular orbitals. If four atomic orbitals combined with each other, they forms the four molecular orbitals. This is the formation of pi bond. Here the formed two are, one is a bonding molecular orbital and another one is the anti-bonding molecular orbital. Similarly, if four atomic orbitals combined with each other, they form four molecular orbitals. In that four molecular orbitals, two are bonding molecular orbitals and two are anti-bonding molecular orbitals. Thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thanks for watching.